Chapter 19, Acids, Bases, and Salts. Properties of acids. They taste sour. Your book says, don't try this at home. I think this is probably the one place you can try it at. You can have lemon juice and vinegar, suck on a lime. However, don't try any cleaning products. They can conduct electricity, making them electrolytes. If they conduct electricity strongly, they're strong electrolytes. And if it's you might remember we used a little apparatus with a light bulb. If it barely lights the light bulb, then it would be a weak electrolyte. It reacts with metals to form hydrogen gas. Again, you might remember our big reaction lab where we did the lab where we put a piece of zinc in hydrochloric acid. We called it the WHOOP lab because we collected the hydrogen gas and inserted the flaming splint, and that's what gave us our little whoop. Change the color of indicators, blue to red as said. And it reacts with bases that are mostly metallic hydroxides to form water and salt. We call this a neutralization reaction. Properties of acids continued. Acids have a pH of less than 7. So our pH scale goes from 0 to 14. So from 0 to under 7 would be considered acidic. And we'll talk more about that later. Acids react with carbonates and bicarbonates to produce salt, water, and carbon dioxide gas. We also did this in our big reaction lab. We had calcium carbonate and sodium bicarbonate, and when you inserted the flaming splint, it went out. How do you know if a chemical is an acid? Well, we've been through all the properties if you were testing an unknown chemical in the laboratory. But as far as looking at the formula, it starts with a hydrogen. So HCl, H2SO4, HNO3, hydrochloric acid, sulfuric acid, nitric acid, but we don't consider water to be an acid. This is a nice little picture. This is George Washington, a statue of George Washington years ago in the United States. And after the Industrial Revolution, we have quite a bit of pollutants in the air, non-metallic oxides combine with water and make acid rain. And you could see that the acid is reacting with the calcium carbonate. So we have bases. Bases are kind of the opposite to acids. Again, mostly metallic hydroxides. They react with acids to form water and salt, so that's the neutralization reaction again. They taste bitter, not sour. If you've ever gotten soap or shampoo in your mouth, you've had that taste, and the same thing here. Soap or shampoo, you notice, is very slippery. Most detergents are bases. And they can be strong or weak electrolytes because they're strong or weak acids, strong or weak bases, just like strong or weak acids. And they also change the color of indicators. We had blue to red as said. We have red to blue base. So there is an example of an indicator. The red paper is now blue because it's been in contact with a base. Another indicator we'll be using is phenolphthalein. Phenolphthalein is clear in an acid, and it makes a nice magenta color. If you can get a very light color in your titration lab with phenolphthalein, that'll be very good. This is just a little scale. You could see that there are more foods that are acidic, I would say, than are basic, more cleaning products. You measure pH by touching the pH paper to the liquid and comparing it to the container. And even though we'll only be using 2 or 3 indicators in class, pH paper, litmus paper, and phenolphthalein, there are hundreds of fascinating indicators and hundreds of combinations of colors.